The exponential distribution is a continuous probability distribution of time. This is a big indicator that we'll be using the exponential distribution. It's the time between events in what's called a Poisson process. So the one thing we should just, like I was saying, a good indicator will be if your question asks you about the amount of time until some specified event occurs, that's a good indication that you should be using the exponential distribution. It is the continuous analog of the geometric distribution. Remember, the geometric distribution was a discrete distribution, is a discrete distribution, and it was where you would repeat an experiment until you got the very first success, and then you would stop. So examples that we could use the exponential distribution for is, what about the amount of time until an earthquake occurs? Or what is the amount of time until an internet outage? Or how long will a phone call last? So the notation for the exponential distribution, x, the random variable, will follow the exp is for the exponential. The parameter is m, where m is the rate of decay. And in the first video, you saw that we said that the PDF was f of x is equal to m e to the negative mx, so m is that rate of decay. Finding the mean of this distribution will be very easy. Mu will be equal to 1 over the rate of decay. And the standard deviation is also very easy because the standard deviation is equal to the mean. Now, to calculate probabilities for this distribution, we will use these two formulas. If the probability is x is greater than some constant k, we will use e to the negative mx, and we'll let x equal k. And if we're looking for the probability that x is less than k, we'll use the formula 1 minus e to the mx, but we'll let x be the value of k that we're looking for. If you happen to be looking for the kth percentile, you will take the natural log, and then it's the natural log of the area to the right, and divide that by the negative rate of decay. Okay, so let's try some of these. Let's let our random variable be the amount of time in minutes that a cashier at a grocery store spends with a customer. The time is known to have an exponential distribution with the average amount of time equal to 8 minutes. Okay, so the average amount of time a cashier spends with the customer is 8 minutes. So what is this telling us? Well, the average amount of time, is telling us that mu is equal to 8. And then, because this is the exponential distribution, that is also telling us what the standard deviation is. So, knowing that, do we know what the rate of k for the rate of decay for the distribution is? Well, we know this. We know that mu is equal to 1 over the rate of decay, which is m. We're given that mu is equal to 8, so we can just solve for m. So if 8 is equal to 1 over m, we can multiply by m on both sides, so 8m equals 1. So the rate of decay must be equal to 1/8. And now we can talk about the distribution for a random variable. X will follow an exponential distribution with the parameter that is the rate of decay, which is 1/8. And we can also say what the probability density function is for the distribution. Remember, as given above, f of x will be equal to m e to the negative mx. M is the rate of decay, so in our case that will be 1/8 e to the negative 1/8 x. All right, so let's do some calculations of probabilities here. So up top I'll just write, if we're looking for the probability that x is greater than some constant, we will use the formula that says e raised to the negative mx, so in this case we'll substitute k in for the value. And if we're looking for x to be less than k, then this will be 1 minus e to the negative mx. And again, we'll let x, when we do the calculation, be the value of k. Okay, so let's start. What is the probability that a cashier spends less than 3 minutes with a customer? Okay, so this is exponential distribution. We've drawn it over here. So here's the number 3. I'll be looking for this area. That is, I'm looking for the probability that x is less than 3. So we can use the formula 1 minus e to the negative m. Remember, m is 1/8. And now the value of x that we're specifically looking for is 3. So the exact value is 1 minus e to the negative 3/8. And if you'd like to find the decimal approximation for this, which will be helpful, we can put that into our calculators and find that it's 0.3127. If we're looking for the probability that a cashier spends more than 10 minutes, well, then this would be the number 10, and now we're looking for this area. So the probability that x is greater than 10, we will use the formula now, e to the negative m, which is negative 1/8 x, but the value of x we're looking for is 10. So as the exact value, it's e to the negative 10/8. Put that into our calculators. What we will get then is 0.2865. And we can still calculate probabilities that go in between two variables. So if we're going in between 5 and 7 minutes, here's 5, here's 7, we're looking for this area. But we do have to get a little creative about that. So the probability that that x goes in between 5 and 7. We don't have a specific formula for this, so what we're going to have to use is geometry and know that that then is the probability that x is less than 7. We could calculate all of that probability and then subtract off the probability that x, let me put that in a different color. Let me put them both in a different color, actually, so we don't get confused. So the probability that x is less than 7 will be the first one. We could calculate all of that probability, and then we could subtract off the probability that x is less than 5, and the remainder would be this shaded area. So for the probability that x is less than 7, we use 1 minus e to the negative m, which is 1/8. And the value of x we're looking for is 7. And then we could subtract off x being less than 5. We use the formula. It's 1 minus e to the negative m, which is 1/8, and the value of x we're looking for is 5. So when we put these in our calculators, make sure you keep as many decimal places so we don't have rounding errors. 0.583138. And then we can subtract off the next probability, which is 0.464739. And when we subtract these, we get 0.118399. Now that we've done all the calculations, we can round these to 4 decimal places, so that would be 0.1184. Okay, lastly, we're looking for how long does it take or how long does a cashier spend with 90% of the customers. So something has gone wrong with the diagram here, but we can just draw it again. Here's our exponential distribution. We are going to be looking for some constant here such that 90% of the values fall below that. Alright, so how do we find that? Well, what do we want? We want the probability that x is less than this constant is equal to 90%. Or remember to change that to a decimal. Okay, well we can do this. We know the formula for the probability of x being less than k. This is 1 minus e to the negative mx. and that has to be equal to 0.9. Right? So this is the equation we're going to solve. We'll solve for x, and that will tell us what value of k we need. So if I subtract 90 from both sides, I get 0.10 on this side, and if I add e to the negative 1/8 x to both sides, we get this. We're trying to solve for x. X is in the exponent, so we need to take a natural log of both sides. Okay. So we get the natural log of 0.10 has to be equal to negative 1/8 x. And then we can multiply both sides by negative 8. So x must be equal to negative 8 times the natural log of 0.10. And then we can put that into our calculators, and we find out that that is 18.42 minutes.